Introduction we did last time, we covered 4 aspects, practical aspects for us as web developers. When we hear this web application security, what it really means for us, it means 4 things. And we started discussing them. What were these 4 things? Just a quick reminder. So authentication. What is the goal of authentication? Establishing the identity of the user. Verifying that the user is he or she claims to be. Once we know who the user is, the next step comes authorization. Authorization is all about deciding the functionality that we should allow the user to do, the resources that the user is able to access. And this is typically based on the role of the user. As I explained, it's better to manage it by permissions by role rather than permissions per user. It's much easier to manage. Then when we are building and developing our applications, sometimes we deal with sensitive data. So we have to ensure that this sensitive data remains confidential. So confidentiality is another aspect of security. Anything sensitive that our application manages, we should encrypt it. And finally, there is integrity. So if our application needs to send a message to another application or within our own application, if messages are exchanged between different components, we need to make sure that these messages are not tampered with, are not changed in transit. And if there is any change, we should be able to detect it. So these are 4 practical aspects of security. You need to build your skills and learn how to do these 4 aspects of security. One more aspect you need to be aware of is to be aware of common attack scenarios and how to handle them. This is just more awareness, and that's what we will do in the last session. So that's what we discussed last time. And just to remind you how this works, so just to exemplify what I just presented. So if I go here and try to sign up, okay. I'll just show you the sign up very quickly here. Yes, here's the sign up. So if I want to create a new user, this is not the sign up. Anyway, it's failed me. Anyway, I had so many examples, but anyway, let me just pick up this one. If I want to create a new user, I would do something like this. And inside here, let me log in and then just explain what's going on. Okay, let me just pick up this. Okay, this is the body. Just to illustrate the sign-up experience. Okay, here it is. So this is a typical sign-up of a new user. So what we will do, we provide a user interface, allow the user to enter their details, and then we capture them in a message like this, and then we post it to the user /user URL to create a new user. So you can see here the password is sent as text. So one one aspect of security is this password is a very important piece of information, shouldn't be stored as plain text. First of all, when we do the login, instead of using HTTP, we should be switching to HTTPS. You can do configuration on the server side to do it. It's very simple. You can look it up. I'm not covering this. So instead of using HTTP, you use HTTPS. That's the first thing. Now, on the server side, when you receive this object, here is the sign up, which is in add user. Here is add user. You can see here when I add a new user, I check if the user has a password. Remember, users that come to our application, they might not have a password in the sense that they can log in using another system. You have seen this in many apps. You can log in using your Google account or your Facebook account or Twitter account. In this case, our system, local system, does not store your password. The password is managed by some other identity provider. But if you happen to log in and sign up and create an account directly with the app, then you will provide the password. So this password, we will not go ahead and store it directly. We have to hash it and salt it. And that's what I explained last time. Just to quickly remind you, so one way to do this is we use this library called bcrypt. There is a very famous library. It has an associated algorithm called bcrypt algorithm. And what I'll do with this library, I ask it, please go ahead, hash this password using a salt and do this 10 times. So let me explain what's this doing. So first of all, we have the concept of hashing. So hashing is nothing but you might have some text, and this text could be of n length. The size of the text is n, of size n, okay? Then you pass it through a hashing function, and this will produce a hash value. Okay, this hashing function, there are so many hashing functions out there. One of them happens to be SHA-256. So you give it any length of text, 1 megabyte, 1 gigabyte, 200 characters, whatever number of characters. It will go through the algorithm and produce 256 characters in this case. Okay. Now, this hash, what we do is, in case of password, for example, here's a password. I give it a password, and it will hash it and produce 256 characters. To make it even stronger in case of storing password, I salt the password. What salting means, I take the password and plus add a salt. What is a salt? It's a random number. Okay, I take a random number, take the original password, concatenate it with the salt, and then hash the two. And I do this in case of bcrypt. I do this operation 10 times. Okay, so take the password, take a random number, concatenate it, hash it, and then do it 10 times. Now, this hashing function, the reason why hashing is so important in this scenario, first of all, by definition, a hashing function is a one-way function. What do I mean by one-way function? You cannot produce the original text based on the hash. So when you get the password, you take the password, you add the salt, and then you hash it. And then you store the salted hash. This way, even the administrator, they will never be able to recover the password. The password is unrecoverable. Yeah? So an example in real life of a one-way function, if you take an egg and break it, that's it. It's a one-way function. You cannot reconstruct it again. You cannot reconstruct the original object. Same thing here. Yes? Why do we go through this trouble of storing the password as hash, as salted hash? First of all, we cannot recover the original password, which is a good thing. Even administrators will not be able to see your password. Yeah? Second thing is, what's the other advantage?
The database gets hacked, nobody, and everyone's password is secure.
Yes, if your database is hacked, your password will not be leaked. The other more important thing is we protect our application against what is known as dictionary attack. As I explained last time, there are millions of passwords out there on the internet. People can download those passwords and start attacking your application by trying to log in using those passwords. And hopefully one of them will match your password. But using this simple technique, because I am adding a random number to the password before hashing, even if you try a genuine password, it will never match one of the passwords that we have in our database. Okay? Yes, please.
So how can we log in if the user with the correct password tries to log in?
Very good.
The number is random, right?
Yes.
So do we store that number? Or?
Very good. Yes. Good question. Very good question. But in principle, if we want to verify the password, we'll have to do the exact same operation. So we take the password. Here's the password coming in from the login screen. We take the password. We take the salt. We concatenate. And then we hash. We produce a hash, salted hash. We compare the salted hash with the salted hash stored in the database with that user. In principle, this is what happened. One naive way of doing it, of course, is to have one salt value, random value, and store it somewhere. Okay, it's still not bad, but there is a much better way. I will show you shortly. Yes, please.
But if you use one value,
yeah,
then if somebody has a list of all the encrypted passwords,
not encrypted. First of all, here it's not hashed and salted.
I mean, if you do encrypted, but you're using the same values, you're not making them random.
No, first of all, as I explained, there's no encryption here. There is a big difference. What is the difference? What is the difference between hashing and encryption? Yes, please.
Encryption is two ways. You can encrypt it and decrypt.
Thank you very much. So the encryption is a two-way function. You can encrypt using a key, and then if you have the key, you can decrypt it. So if the administrator if you use hashing for storing password, administrators typically have access to the keys. If they access the key, they can know the password of anyone. Okay. So encryption is not a good strategy to securely store password because they will be not secure against internal attackers or other administrators being able to access the password. So that's why encryption is not a good idea for storing password. The best way to store password is to do what? Hash and salt. Hashing alone is one-way function and you are fine. But to make it harder for dictionary attacks, you add a salt. This way, even if some people have a list of passwords and they try them against your app, they will not succeed because you don't just straight away hash. You take the password, you salt it by adding a random number, and then you hash it. Yes? So basically, you have a one-way function plus protection against dictionary attack by doing salted hash. This way, the password is unrecoverable. So now, when somebody wants to log in, they give you a password. You take that password, you add the same salt you used originally, and then you produce a salted hash, and you compare the salted hash associated with the account with the salted hash produced based on the password supplied during the login. If they match, then this is a correct user, otherwise authentication will fail. Now, to solve this problem of storing salts, there is this bcrypt algorithm. You can look it up. I'm not being able to explain it at this stage. But there is an implementation here, bcrypt.js npm. There is a famous library called bcrypt.js, and that's what thousands of people are using. So let me show you how it works. All it does, you import this library and you say, go ahead, please, and hash this password for me, and do this salting 10 times. I'm not giving it a salt value, by the way. It generates its own salt value, and it does it in many iterations. Now, the password that is produced this password that is produced, this is a salted hash password, and it includes the salt. Yeah? Somehow, in the algorithm, we can look up the internal working of the algorithm. But I can see there's some little number there, number 10. Can you see it here? The number 10, the number of iterations is stored somewhere. So basically, the bcrypt algorithm, it knows how to, during the comparison, it extracts the salt values that were used when producing this hashed password. It extracts it from the salted hash password. So the salted hash password includes the salt. So we don't need to remember the salt or store it somewhere. It is already included in the hash. So when we have a login, here is the login. When I have a login scenario, all I do, I will look up the user by email or by username, and then I'll go ahead and ask bcrypt, exactly the same algorithm. I'll ask it, please go ahead and compare for me the password supplied by the user during the login with the password that is stored with the user account. Compare these two for me. And I imagine bcrypt will go to this stored password, extract the salt or extract the salt values, and do whatever steps that were used to produce this hashed salted password. It will do the same to this password coming in the login, and if they match, then the authentication will succeed, otherwise the authentication will fail. Is clear? Yeah? Okay, so this is one technique where to ensure confidentiality of our passwords, at the same time protecting ourselves against dictionary attacks. Of course, dictionary attacks, one more thing you would do, I didn't do here, is that to limit the number of attempts to log in. You know, in most applications, you have 3 attempts. After the third one, if the authentication failed, what will happen to your account? It will be locked. Your account will be locked. You will not be able to use it. You have to call some call center or do some process to recover to reset your password or do something. So that's another protection mechanism against dictionary attacks. So you protect yourself against dictionary attacks by hashing and sorting the password and by limiting the number of attempts to a certain reasonable number, typically 3. Is clear? The hashing and the sorting. Okay, yes, please.
The salt,
yeah.
The random number is generated by the
bcrypt, yes.
itself. We are just specifying how many times you want.
How many times you want, yes.
So again, when someone gives the password again, basically it will try to extract from the hash the random number it used and also the number of rounds.
Yes, the inner working of bcrypt, we have to look it up. I didn't really have the chance to really dig into it. But conceptually, what is more important to understand is to understand this. That the salted password, the salted hash, the way it is produced, you take the original password, you add a random number to it, and then you hash it. Yeah. The produced hash is a salted hash, and that's what you store in your database. Now, the naive way is to use one salt, as I mentioned, and you store that salt and you do this process. A more sophisticated way is to use this bcrypt algorithm. It's well known. You can look it up in Wikipedia. I didn't have a chance to go through it. And it will do this for you. Plus, it will store the salt and the mechanism to generate basically the salted hash. All the parameters needed to apply those steps during the login is stored with the salted hash password. How it is done, like we need to look up the details of the bcrypt. But conceptually, this is what is important. Is clear? Yes. Okay. So moving on, now we'll start with the authentication. You get the story here of sign-up. The only thing interesting here, you already know how to take an object and store it in a database or file. Simple. The only thing to keep in mind, we don't store the password as it is. We go ahead and do salted hash using bcrypt. bcrypt.hash, and we do so. And then when we want to log in, we do bcrypt.compare. That's how we do it for managing passwords. Say I provide a login screen. The user will type in their email and password and click login. When they click login, I generate a post request it will go to users/login, and I provide this object. And what I'm expecting to get back? A user object. And typically it has some information about the user, and more importantly, the role, and this is important for authorization. Because once I log in, the system knows who I am and knows my role, and it will configure the menus, it configure my access based on my role. Now I logged in, system's supposed to know who I am. It's now time to start asking the system to do some things for me, such as asking the system, give me the users, authorized, 401, unauthorized. For 401, if the authentication failed, you get 401. This is the correct code to return to your client. 401, unauthorized. If I'm already logged in and I get denied access, I should return 403, forbidden. Yes? Now, I already authenticated. Here is the evidence. Here is the evidence. I go back here, log in again. Here is I authenticated, and I get a user object back. When I try to go to users, send it, it's telling me unauthorized. What's going on here? I logged in, I go to user object, I came back to the system and say, system, please give me the list of users. The system is telling me you are unauthorized.
That's not being saved.
Unauthenticated.
It's not being saved.
It's not being saved. What is not being saved?
It's not being saved.
It knows the person who logged in.
Very good.
Isolated to that session.
Okay, very good. Very good, which means what you're trying to tell me, of course you're trying to tell me this in a simple way, but really what's going on here, by definition, very important concept, by definition, the HTTP and by design, HTTP is stateless protocol. And a web application, by design, it's a good idea to keep it stateless application. What is the meaning of this big keyword here, stateless?
It doesn't have a state variable. It means it doesn't have it from its application, right?
Very good. So you ask it to do something for you. It does it. Does it keep anything in its memory? Does it remember anything from the request you ask it? It's not supposed to. So it serves your requests and forgets about that request, forgets about the results produced. It's not keeping anything in memory, which means this design is stateless. Every request is a new request. It does not remember the previous things, which is good. Why this design is good? I want one keyword. Why this one is good? No. No, not really.
Security?
No. This one is very, very important for one big reason, which is scalability. What does this mean? What does it mean?
Ability to serve more customers.
Ability to serve more customers. Very good. If the web server or the web application starts remembering things as you interact with it, especially if it starts remembering them and storing them in memory, what happened to this server? At certain stage, it will be overwhelmed. It cannot cope anymore. It cannot handle a large number of users. And because now it is stateless, it is by definition and by direct result is more scalable. That's why we have to try our best to keep our applications stateless. They don't remember anything. You just deal with them, you ask the server to do something. Once the server finishes your request, what it will do? Return you the results and remember nothing. Next time you come, it says, who you are, I never seen you, I never did any interaction with you. Yes? So it's a good property, of course, it's a good property. And even in the real world, people that are stateless, or try to be at least as stateless as possible, they are more happier, they have better social life. Like they let go. The stateless means let go. So for example, when you have some bad thing with that person, they will not remember it. Oh, I achieved this, you didn't say Mabruk to me, or you didn't come, you didn't greet me, and they keep this for 10 years. They remember it, and basically they give themselves and others hard time. Yeah? While others that let go, if there is something negative, they just kind of brush over it and move on. They are more happier. Of course, they can have better social life. They have more friends and so on. So that's basically kind of the idea here. Stateless, don't keep anything. Serve the request and keep moving on. Yes, please.
So if we wanted to simulate some sort of state with the user here, we would do it locally on their machine, and whenever you send the request, you send whatever information.
Very good. Excellent. Yes. So the best way is where to keep the state?
On the client side.
On the client side. Thank you very much. You saved it. You made my life easier. So the idea here, of course, there is a state, and it's important to keep this state. Otherwise, every time I come to the system, I have to log in and ask you who you are. I don't know you. Log in again so I can know who you are. Yes? So instead, you log in once, you get what the login returns you, you keep it. Whenever you come back to the system to do some other actions, you have to you have to give the system a user object. Is clear what's going on here? So, but the idea here, this is very good. The idea here, you can see in here I am getting user object. But it will be very inconvenient. Look at this user object, very complex and lots of JSON objects with curly braces and scary stuff. I don't want to take this object and send it over and over every time to the request to the server. Plus, you know, here the admin. Suppose my role was a normal user, contributor. I can change it to admin and try to trick the server. So sending this user object as it is not a good idea. So what I will do here, I'll take this user object and I will basically convert it to a string. Take a look at this. After I log in, oh, here it is. So instead of returning you the user object, I create what is known as an ID token. Let me first run it and show you what it's supposed to return rather than a user object. Here it is. So I go back here and log in. And now, instead of getting a user object, what I'm getting here? An ID token. Yes? Now, what I do with this token, what do you think? Whenever I go back to the server to request something, I should do what? Send this token as well. So the server will remember me. Will recognize who I am. So, and this state, who should keep this state? The client, not the server. The server, we want to keep the server stateless. Why do we want to keep the server stateless? To keep it scalable. That's the reason why. Okay, that's what I mean here. You really need to learn the technical words, because if you just say scalable, khalas, we know what you mean. When you say stateless, we know what you mean. So that's where the terminology really helps to basically express yourself. Yes? So summarize. So I log in. When I log in, what do I get back?
Token.
An ID token. Yes, please.
How can I use this ID token?
Very good. It's coming. Okay, first of all, let's try to see what this ID token is. So let me just show you. If I take this ID token and take it to the web and ask this web JSON, it's called JSON Web Token. JSON Web Token. JSON Web Token. Okay. There are many utilities on the web out there to make sense of these scary characters that I have there. So if I paste them here, I paste there, it tells me, oh, this scary number, it is nothing. It is just an object. This object has 3 parts. These 3 parts, there is a head. It says that this is a Jwt token, and it says this algorithm I will explain shortly. And it's the body is nothing but the user object. There's nothing scary here. It's just the user object. And at the end here, I have a signature. Okay, there is another tool. It shows it in a much better way. There's called it's a plugin to Chrome called Jwt Inspector. So if I open it, you can see it shows me very clearly. That string there, by the way, that string is a base 64 encoding. For base 64, please look it up on Wikipedia. It's an encoding. If you are familiar with binary encoding or hexadecimal, it's just another encoding. This is base 64 encoding. This one is, there is no encryption here or nothing. Don't get it, don't be confused. It is just encoded in base 64. Why did I encode it in base 64 instead of keeping it in plain JSON?
To be able to use it in the URL.
Yeah, and yes, very good. Thank you very much. It's much easier to deal with as one string rather than as an object. The other thing is, it is signed. This object is signed. You are familiar with what signature means? Okay. Signature is all about protecting integrity. So let me explain what signature means without making it a security course, just very quickly. So back to, remember, back to hashing. Remember in hashing, we have some text of size n. We take it through a hashing algorithm such as SHA-256. And what this will do for us, it will produce a hash. Hashing is clear? Yes. And this hashing is, as we said, one-way function. Yeah. So in this case, what I'm doing, I can put here the user object, take it through SHA-256, and produce a hash. So far as I'm just doing hashing. Second thing, what I'll do with this hash, I take this hash and encrypt it. Encrypt the hash. And this will produce what is known as the signature. So what is a signature? It's an encrypted hash. It's an encrypted hash. And to do the signing or to produce the signature, I need a secret key. So I take the hash and sign it and basically encrypt it using a secret key. So what's going on here? Take a look at this. All this part, how this part is produced, this signature, how is it produced?
By hashing the...
All it's doing, it's taking this payload here, yes? Taking this user object, hashing it, it produced a hash. And then what we do with the hash? Encrypt it. And all this, which algorithm are we using to do this? HMAC SHA-256, which basically we're doing here, HMAC SHA-256, this is exactly what I just explained here. I took the user object, I hashed it using the SHA-256 algorithm. This will produce 256 character hash. And then what do I do with that hash? Encrypt it. Okay? And I will explain to you the role of signature very shortly. But for now, all I want you to know, let's go back so we don't get confused. When I logged in, what did I get back from the login? From the login, after I logged in, I got an ID token. Now, this ID token, what does it have? It has the user object encoded in base 64, and it has a signature attached to this object. So you can see here, if you look carefully, it's not clear here, but if you look carefully, there is 3 dots in this string. I cannot see, yeah, they are here. Can you see it? There's 1 dot here, 1 dot here. So the JWT token is nothing but a string made up of 3 parts, separated by a dot. What is in the first part? It's just a header. What the header says, don't be scared. This is a JWT token, and it is signed. Which algorithm was used to sign this JWT token? HS256, which is basically HMAC SHA-256, which is nothing but taking this message here, the user object, hashing it using SHA-256, and then encrypting the hash, yes, and producing the signature. So the last part is the signature, and I will explain why this signature is so important. So first of all, once I log in, I get this access token. Once I log in, I get this access token. This access token, I should keep it as a client. And then whenever I go back to the server and ask for something, I should communicate this ID token back to the server. Otherwise, the server will not recognize who I am. So how do I communicate this ID token back to the server? What? Yes, in where? Passing it in where? No, not in the body. It is standard way of passing it in the header. And which header? Do I choose any header? There is a header, well-known header in HTTP protocol called authorization. And then I put this keyword bearer, and then in here, I go ahead and paste this here, okay? Bearer is just a standard term, like a kind of legal term. You know, something you get a check, it says, pay this to the bearer. It's like lihamili, pay it, whoever has this check, give it, present the check, you get the money. You don't need to verify any identity or anything. This one, because this one's very dangerous, anybody has this key, khalas, they can get what they asked for. There's no verification. They will not ask you for passport in the bank or anything. They pay it to the bearer. The check does not have a kind of a name. Anyway, it doesn't matter. The way we do it here, we put authorization header, bearer keyword, space, and we paste the ID token that we received. Yes? Now, here it is, send. Now the server knows who I am and returns to me what I asked. What I asked the system to return me? The users, the list of users. Okay. Now if I disable this one and try, of course the system says unauthorized missing JWT token. As soon as I add the authorization header, system is happy and it gives me what I asked. Now, if I try to trick the system and say, oh, I am only like student and I want to log in as administrator and I play with the object. You see, because this is plain object. Remember this? This is plain object. I could come here and say instructor or super user or whatever and try to encode this in base 64 and send it to the server. Okay, let's try that. If I go here and try to trick, just instead of 1, put 2. Yeah, send, says forbidden invalid JWT token. You cannot trick the server by changing the ID token. Why the server is able to validate this and detect that there is a change of the token? The signature. Remember the 4 things in security: authentication, authorization, confidentiality, and integrity. How do we achieve integrity? By using signature. Okay. So what is a signature?
Hashing the token and then encrypting.
No, hashing the user object and hashing the user object and then encrypting the hash. Now to encrypt the hash, what do you need? Secret key. Who knows the secret key? Only the server. So you can change the object the way you wish, but as an attacker you will get stuck to generate the signature. You can change the object, but you cannot generate the signature. Why you cannot generate the signature? You don't have the key. So you might change the object, you send it to the server. What the server will do? The first thing it does before it serves your request, once it gets the ID token, it will take the ID token, extract the user object, hash it, and encrypt the hash. If the two match, the the signature generated matches the signature coming with the message, then that JWT token is valid, otherwise it has been tampered with. Okay, so let me summarize all what we have seen before we move forward. Here it is. So what's going on here? This is the modern way of doing authentication on the web. This is the proper way of doing it. You come along, you do a post request to log in. You supply an email or username and password. The server will do whatever it needs to do. It will go and get your object, your user objects from some database or file. And then what it will do with that user object? Use it to generate a JWT token. To generate the JWT token, what does it need? It needs a secret value, a secret key. Secret key is nothing but a string, similar to password. You can choose any string you wish. Then this JWT token is returned as a result of the login. So after you log in as a client, what do you get back at your hand? A JWT token, which is basically an ID token. And the format of this ID token is called JWT. It stands for JSON Web Token. Now, what you do with that ID token that you receive from the login? You keep it. And then whenever you want to access other resources from the same server, make sure you send that ID token with your request. How do you send that ID token? As a header. Which header? The authorization header. And the way it should be written, authorization header, bearer, space, and you paste there your ID token. On the server side, when this ID token is received, the first thing, the server will verify that that token has not changed. How the server is able to do this? Thanks to the signature attached to the ID token. If the verification is successful, then that ID is not madroub. That ID is genuine. Sorry, that ID token is genuine. And then the server is able to reproduce the user object, and it will verify the role. The ID token doesn't, if it's valid, it doesn't mean you get access to whatever you asked for. The server will look at the role, say, oh, you are asking for users, you should be admin. Do you have admin role? Yes, it will allow you. Otherwise, it will deny. Is clear how it's going? So let me give a little bit more explanation. Just to make it clear in terms of the signing, I want the signing to be clear. First of all, let's look at the hashing, because the hashing is the building block for signing. So it's clear the hashing, how hashing works. So I take a block of text of variable length, take it through a one-way hashing function, such as SHA-5256. And this will produce what? A fixed length string. And this fixed length string really represents a fingerprint of the message. I showed you last time, if you change the plain text with one character, the hash is completely different. So powerful idea here, okay? Now, the hashing alone, it does not give you any security. Hashing alone it does not give you security. Now, how do I take advantage and extend this hashing to make this string produce secure? This hash, when it's produced, I take it and encrypt it using a secret key. Okay, when you do that, there are many algorithms to do this. One of such algorithm happens to be called HMAC, hash-based message authentication code. Hash-based message authentication code. And one of these HashMax algorithms, very famous one, is called HashMax SHA-256, which means it's produce a hash value of 256 characters, and then it will encrypt it. So the way it works, here it is. So I take a message. In our case, what is the message we're trying to sign? The user object, thank you. Here's my user object. I'll take it through an HMAC function with a key. A key is nothing but a string that I choose. So the hash MAC takes two inputs, the user object and secret key. And what does it produce? A hash. Yes? Now, when I get this, this is basically my ID token. This is my ID token. Remember, the ID token has three parts. What are these three parts? The header, the object itself, and the signature. How the signature was produced? Using this HMAC SHA-256. In the header, how do we say this HMAC SHA-256? We just say HS-256. Yes? You remember this? In the, yeah, it says here HS-256. Nothing secret here. It's telling you that this signature was produced using which algorithm? HS-256. You can look it up. Even as an attacker, they are familiar with this. If I do here HMAC, you can see it. Even Google knows it. SHA-256. You can look it up and read all about how it is done. There's nothing secret here. Yeah.
So basically, if I know the secret key, then I can
yes. Yes. Yeah. Nothing is secret here except the secret key. That's it. That's all that is secret. Now, on the server side, when you return back this ID token, will the server just trust you and just get the user object from that ID token? No, the first thing it will do, it will take the message and the hash. It will take the message and do exactly what was done here. It will hash it using the secret key. Of course, the server knows the secret key. And it will take the user object from the message, do an HMAC using the secret key, and produce a hash. Then it will compare the hash coming with the message with the hash reproduced on the server side. If they match, if they are equal, then the ID token is authentic. It has not been tampered with. It hasn't changed. If they don't match, the ID token was played with, and it will be rejected. Is the idea clear? The signature, how it is done? Okay. 1 minute, sorry, I'm really sorry for this. Let me just show you. Here it is. This is how I sign, one line. All I do, I say JWT, this is a library called JWT, sign, and I give it a user object, and I'll say, here is my secret. Secret is any string. In this case, my secret is this one, my JWT secret key. Okay, and here I'm asking this JWT to expire in 2 hours. You can get this ID, you can store it. In 2 hours, you can keep using it. After 2 hours, that ID will no longer be valid. It will be thrown away. Okay. Now, when you come back, when you come back to the server, what the server will do will bring your ID. This is the ID token coming in the authorization. Can you see it here? I go request.headers.authorization, and I'll go, you see the second, I split this token, and the second part, the JWT token, please verify this token for me. Here is the token and here is the secret. Verify if this is authentic or it has been tampered with. Reason why here I'm doing this, remember, the authorization has bearer space string.
Okay.
Remember? Yeah, the authorization in here. Sorry, here. Yes, even neglecting the bearer, just getting the token. Once I get the token, I verify it. And by the way, verifying, it verifies and gives me back the object itself.